Alright, it's going to be part 2. We're going to be doing the Pythagorean identities since we abruptly cut off at this reciprocal identities. So let's start with the unit circle here with a radius of 1. And we form a right triangle here with angle theta with some x and y coordinate. Now from here we already know that the sine of theta is just the opposite over hypotenuse. This opposite being the y coordinate, which is y. The length, this, same thing, which is y, and the hypotenuse, which is 1, which is essentially just y. So there we have that. This can be sine of theta. Now for this one, the cosine of theta is just the adjacent over hypotenuse, which is just this length x here over the hypotenuse, which is 1, which is essentially just x. So here, this is x. This is cosine of theta. Now what about the other what about the 4 other trigonometric functions? Well, look at this right here. Let's name this distance d, right here. And as you can notice from this crappy line, it's supposed to be tangent to the point on the circle, and obviously the tangents are perpendicular to the length of the radius here. And since they share this angle theta here, this triangle here, this triangle here, and this triangle right here, they're similar. They're similar. So this means we have two triangles. Let's name this length here E, and this length here D. Now see this one's 1. So from this here, we already know that this is a sine of theta, and this is the cosine of theta. Just let me write this down. And here we have 1. Now from here we know that this here is just 1. This one is touching angle theta. And wait, hold on, let me indicate this. So this here, it's touching angle theta and the right angle here, so this is 1. And this here is just only touching the right angle, so this is D. And we have E here as our hypotenuse. Right. So from here we can use ratios and proportions. So this here, this and this over this is equal to this over this. So D over 1 equals sine theta over cosine theta, which is a tangent of theta. So this is actually our tangent. This is our tangent distance right here. And what about E? We can use the same thing. So E, which is this, no, E over 1 is just 1 over cosine of theta. Which from here, from the reciprocal identities, this is just secant of theta. And so this is actually the secant theta right there. And we only have like two more. Let's extend this line here. Draw another tangent line. And we're gonna name this length F and this length G. Alright. So obviously let's just use this. Let's use what else? What else other variable? Like let's just do lambda, for example. There's gonna be angle lambda right here, which is just equal to 90 minus theta right there. Let me use alright. Obviously from the same thing, but also there's also gonna be cosine of theta right here. You can understand why. Alright. There's gonna be another right angle here. So same thing again. Since these two triangles share the same angle lambda, this just means that these, and also this one's right, this is a right angle or whatever. This is a right angle. These two triangles have right angle and they share the same angle lambda. That means these two triangles, see my cursor there? Those two triangles are similar. So let's draw a triangle there. So this here is the length, this is hypotenuse one. This touches me on alright. So this is touching the right angle here. So this is just the cosine of theta. Oops. Alright. Please. And this length here is just sine of theta. Of course, you can see why. Alright. And here you have one, which is just this, which is touching, refracting the right angle and the angle lambda. So this is one. And it's touching the right angle here. This is length G. And this wing here is just, and we do the same thing. Alright. Let's do F here. F over 1 is equal to 1 over sine of theta, which is just equal to the cosecant of theta. So here we have cosecant of theta. And from length G, we can do the same thing with G. G over 1 is the same as cosine theta over sine of theta. So, which is just equal to the cotangent theta. This is cotangent of theta. So let's rewrite this. Let's clear this up a little bit. So we have a unit circle. Draw a circle. No, let me draw a circle from here. Oops. Well, you know what? We're just in circle. Boom. Alright. So with with the length of radius 1 and with an angle of theta, drawing a line from here. This length here is just sine of theta. This length here is just cosine. No, yeah, cosine of theta. This this length here, tangent to a point on the circle. That the length of this point on the circle to this on the x-axis, like the point tangent. This is a line segment. It's tangent the circle. Sorry, I just wing it. This is just the tangent of theta. Alright, this is a tangent line, obviously. And this length here is the secant of theta. And if we draw a line here, another tangent line to the y-axis right here, this length here is a cotangent of theta. Is this here, this tangent right here, and this length here is just the cosecant of theta. So how can we get the final three Pythagorean identities here? Sure. Since this is already a right triangle, and we know that the Pythagorean theorem is just this squared plus this squared equals this squared. We already have one of the identities here. So cosine or the square of the cosine, which is cosine squared theta, plus the square root of the sine theta, which is a sine theta sine squared theta, We add those together, we get 1. So that's one of our Pythagorean identities. And from the second one, we already know that this is a right angle since any tangent on any tangent line is just perpendicular to the radius, to the length of the radius right here. So we get 1 plus tangent squared theta equals secant squared theta. So let's write that down. 1 plus tangent squared theta equals secant squared theta. There. And for our final Pythagorean identity, we can just use the same thing here, using the same property as this. This tangent line is obviously just perpendicular to the length of the radius here, and it's just the hypotenuse since it's opposite to this right angle here. So we get 1 plus cotangent squared with theta equals the cosecant squared with theta. Let's write that down. Equals cosecant squared, well, cosecant squared theta. There we go. Alright, so these are 1, 2, 3, 4, 5, 6, 7, 8. These are 8 trigonometric identities. All finished right here. We'll learn how to apply these like next time, maybe tomorrow. So I just want to let this sit here so that you guys get to know these identities a little bit more. Alright, I'm out.